Very tasty. This is my second video about molecular equations, or overall reactions, as I sometimes call them. Total ionic equations, net ionic equations, and spectator ions. In this one, it's going to be solid calcium carbonate and aqueous hydrochloric acid that are mixed. Both of these can be broken up into ions. Hydrochloric acid is a strong electrolyte. Calcium carbonate is an ionic compound, but it is not a strong electrolyte. It is insoluble. And we can still do double replacement reactions and the full analysis with these. So calcium is calcium 2+, that's our positive or cation. Chloride is our negative ion on the other species. So one of our products is going to be calcium chloride. Leave some space for the phase there, although I can already tell you that almost all chlorides are soluble. There are a couple of exceptions, but calcium is not one of them, so that gets the aqueous. Here then we have H+ and carbonate minus, and it's important that we put them together for the compound so that the charges cancel. Our other product is going to be carbonic acid, and carbonic acid, when it is a product, is a gas-forming species, and so immediately we cancel out or cross it out and write H2O liquid plus CO2 gas. And if we did this reaction in class, or if you Google it, you'll see gas bubbles form. So that's our evidence that even though our product is listed as carbonic acid, it breaks down spontaneously into H2O and CO2, carbon dioxide. And CO2 is also the gas in carbonation. And so what happens when you open a bottle of carbonated beverage is that spontaneously the carbonic acid breaks down to make more carbon dioxide, and that's why you get bubbles in it. Of course, there's also carbon dioxide pressure in there to create the carbonation. That's why you get that nice big burst. But you are watching bubbles of carbon dioxide form over time as carbonic acid breaks down as well. From here, to make our total ionic equation, you go ahead and anything that is a strong electrolyte, like hydrochloric acid and calcium chloride, those are going to break down into ions. Solids, liquids, and gases stay together. So calcium carbonate stays together. Oh, again, I always forget to balance it. I have 2 hydrogens, so I need 2 hydrochloric acids. I have 2 chlorides on both sides, so that should balance it. All right, good. So then I get 2 hydrogen ions plus 2 chloride ions becomes calcium ion. This is a strong electrolyte. It breaks up into ions. This is 2 chlorides, and our liquid and our gas stay together. So same process as the previous one, except if you're paying careful attention to what gets broken up and what does not, I mean, it looks pretty different. Now, like before, we can cross out our spectator ions. I only see one thing that is identical on each side. That's going to be our chloride ion, which we can list as chloride ion or 2 chloride ion. Either way is fine. And then write what's left. And so not much cancels out. And what we can do is, after we write our net ionic equation, we can ask it what bonds formed, what bonds were broken. And in fact, because we have the solid on the reactant side, that's a Q, goes to calcium 2+ plus water plus carbon dioxide. And then again, you can ask it what happened. So what kind of bonds formed or were broken or both. It looks like ionic bonds were broken here. So ionic bonds broken. And we know that because calcium and carbonate have an ionic bond on the reactant side, but they do not on the product side. And then we have H pluses by themselves, but they're now forming covalent bonds to make molecules. So ionic bonds were broken and covalent bonds were formed. And that's why we're interested in the net ionic equation, because we can ask it questions and get answers like this.